So in preparation to show you what the machine is capable of doing, I've got some 40 range brass here that's just been cleaned. This is the pan that I throw my brass in and I spray it with one shot. Dillon case gauge, which I've always been told was pretty forgiving. Okay, I can jam this in there, but I'd have to pound it back out. So we're going to identify this one as kind of crappy. It's a Winchester. Oh, that one's fine. You know, we get some brass. That's not bad. You know, there's no reliable way to say the range pickup is pretty good, pretty bad, whatever. You're going to have to check it traditionally. And traditionally, you're going to have to process it somehow. What I'm trying to do is show you that no processing is needed. Just definitely identifying cases that, yeah, there's no way how, that just won't work. These would normally, on any motorized unit, it would jam. Okay? And while I'm doing this, which is incredibly boring, let's discuss when I mean the word jam. On every machine, motorized machine that I have ever worked on, a jam indicates that it had a problem going from point A to point B. And since it is a, quote, dumb machine, it doesn't think, it doesn't employ any logic, and there are no outside variables on it, it is still continuing trying to go to point B. Well, that continuation from point A to point B just basically loads up force on it, and what it's trying to do is it's trying to overcome that piece of brass in order to continue to get to point B. When that shit gives way, literally it's like, you know, instead of the gun K-booming, your machine K-booms. Everything that's in process goes flying around, turns into a frickin' projectile. I've heard tell of a guy who had a 9mm case embedded in his chest from the force coming off of a motorized machine. In those situations, even if it doesn't screw up your press, it is imparting way too much torque, force, current, everything on the motor trying to get from point A to point B. This is not a good thing. All right, so I've identified some really crappy brass. All right, next we're going to run really crappy brass. We are going to run them. All right, and what I'm going to do is I am just pure and simple going to drop them in top of the feeder as if they're coming out of the case, because I don't want to. We'll do a couple single cycles, but truthfully, it's far easier just to see it run. And I'm not going to show you the screens. Nothing's happening on the screens. I think it's more important that you actually see what the press is doing in a motorized deal. So we have already calibrated. Everything's good to go. I'm going to set it at 1,200 rounds per hour. We have a plate delay of 1. We have a bottom dwell of 1. In other words, a bottom delay of 1. And I've dropped in, oh God, I'm not 100% sure how many I dropped in. How many ever identified earlier? If you were counting, that's great. We will know how many when they land in the bucket. And, barring unforeseen complications, we are going to run. These were the cases that would not go in the Dillon case gauge. Last one, end cycle. All right, so this is what we've got. And I'm going to turn the, well, now you know what? Let me do this. The production values here are as wonderful as it gets. Okay. I'm just like the new commercial. Shot on iPhone 6. Oh. These are the ones that were clearly identified that would not work. Just make sure I'm there. All right, beautiful. 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 And we can keep doing this till hell freezes over. They're all going through an EGW Lee undersized die. For those of you that know exactly what that is, you'll know it's it's enough to drag down most machines, and we're working with the digital clutch of 3. Look, I can keep doing this till hell freezes over, but realistically, I haven't found one yet that came through either the machine with the Mark 7 or just pulling the handle. If I can get it through, it fits the gauge. All right. Okay. I've identified some really problematic cases that you would potentially find. There's one. Here's another one. And here is the mother of all problems, if I can find the camera. There we go. That would be a 40 caliber. Let's see if we can get it to focus. 40 caliber with a 9 stuck inside of it. Okay? So what we're going to do is we're going to single step these through the press. We're going to single step these through the press. Okay? We're going to assume that it made it through. All right? We have a digital clutch of 2, and we're going to try this one first. It cleaned it up quite nicely. That's a digital clutch of 2. All right? The next problem child, clearly identifiable. We're going to drop the clutch to 1. All right, limited amount of force, just so we don't have a problem in the swage. I'm going to take that out. Digital force of 1. Yeah, cleaned it up. It's functional. All right, so we don't have a problem in the swage. Let's go in with the true problem child. And I'm going to just automatically assume that a digital clutch of 1, I'm not going to run at 1. I'm going to run at least 2, if not 3. I've moved the digital clutch to 2, and we're going to single cycle this as well. And it found it. It realized there was a problem. We're going to jog it up. And I'm going to remove it. The primer is still on the bottom. I'm going to assume the 9mm is still there. What I'm going to do is I'm going to end the cycle. And I'm going to replace the 9mm inside of 40. And I'm going to raise the digital clutch to 3. And I'm going to single cycle it. And once again, it found a problem. You notice that it did go a little bit deeper this time. Had a little bit more oomph, but it did find the problem. If you're running at 4 and 5, you're probably running dry, or you're probably not doing 40s. All right, so once again, I'm going to jog it up. And I'm going to remove the case. It started to press the primer out, so it did indeed make it through the 9 had a little bit more force and started to poke that primer out of there. Realized, hey, wait a minute, this is probably not good. So, all right, now just for grins, this one was clearly ugly, and I ran it at a digital of 2, and it cleaned up quite a bit. This is still pretty damn ugly. So what I'm going to do is I'm going to run it back through sizing, and I'm going to run it through the swage. If you know anything about a swage, it often rounds out the inside. Well, let's see what happens. And truthfully, if I was running this machine, I would probably toss those cases before I even got started. So we're on a digital clutch of 3. I'm going to put it at 2. Okay, it left a dent. Let's see what happens here. And when I went to the swage, it opened up the inside. So a digital clutch of 2 technically recovered this. You know, there's some people out there that would see this little dent right here, if I can get it focused. You see this little dent or whatever, someone will blemish and call it bad. Like I say, if I'd have seen this when I was prepping the cases, you know, throwing them in the pan, getting ready to spray them, if I'd have seen it, I probably wouldn't have thrown it in the hopper. But it is good to see that it will recover as opposed to just arbitrarily reject, that which most of us probably would have rejected.